Hi, this is an introduction to the 3D Studio Max plugin Wrapit. Wrapit is a tool for conforming low poly meshes to high poly meshes, and a retopology tool really. It was created back in 2009 initially. There wasn't an awful lot on the market back then for this sort of thing. I've continued to keep it updated to work with current versions of Max. I still use it. I know there's plenty of people out there who do still use it. Back in 2009, 2010, it wasn't really a thing where you created these HD sort of tutorials that have become so commonplace, and I still do get requests for them, so I thought I'd just go back now and just go through all the main functions of Wrapit and how it can be used. So to start with, we're just going to look at the basic functionality of Wrapit. When you open the menu, you'll be greeted with this. We have high poly and low poly. So for now, let's just create a sphere. We'll make that a bit smaller. We'll make it nice and dense. This represents our high poly object. We can select that. Once that's selected, we won't be able to do anything with it now. That's frozen. Wrapit's now cached this, and we're ready to add our low poly object, which is the object we're going to wrap to this object. So I can create a cube in this instance. We'll knock up our segments to maybe 10 per side. Just going to move this down so it covers up the high poly object. We'll select. We'll select that. It's just going to give you a little warning now. If we were to have modifiers in the stack for this, it would keep their modifiers, but it would always turn the base layer into an editable poly object. Okay, and that's done now. We'll have this little toggle edges here, which can help. The bar here is a crossfader really, so we can see the high poly object and the low poly object. And if any time we don't find a balance here that we like, you can also just override both the high poly and the low poly to find the balance you like if you want to visualize both. Now the real magic starts here with the auto wrap function. When that's on, Wrapit will always monitor the verts on the low poly object and snap them to the surface of the high poly object. So if we switch that on now, instantly wrap to the surface. And if I try moving these objects around now, when I release the button, they snap, and you'll see that works on any. We can select multiple verts, we can select faces. They'll always snap back to the surface. You'd end up getting in a mess. But then I think one of the other more powerful features is that you can select and relax over the surface, and it will pull tight over the underlying surface. Now when we're in the auto wrap mode, the real power of Wrapit is that it allows you to use all your normal editable poly modeling tools, and it will just simply, after the edit is made, it will continue to conform to the surface. An example of that may be if we were to select an edge and shift extrude that edge, you'll see that it's going to snap to the surface. If I pull it right here, it always snap back and stay on the surface. Anything you can really do in here will update and snap. So in that respect, Wrapit's not really adding a load of extra tools, certainly at its most basic level, but it is allowing you to use the tools that you're familiar with. Soft selections, you'll move things with a soft selection and snap. You can even do things like if we select an edge here and an edge here, I'll just turn off soft selection, that doesn't need that for now. We can bridge. Now it won't work obviously until we've confirmed this dialog. So if I put in a number of segments there and confirm, it didn't. As you can see here, it didn't conform. And the reason behind that is To make things faster, Wrapit is always working on the current selected sub-object. So in this case, it's these two edges. Now, 99% of the time, if you're working anywhere in the Edital Poly rollout, the part of the mesh that's being edited is the part selected. But in certain tools, like the bridge tool, for instance, the edit is made here, the bridge bit isn't selected. Now, you can force a refresh here with this little button here, and you'll see they'll all pop out now. Or you can have this brute force method on, and that will just force Wrapit to reevaluate the entire mesh rather than just a selection. So then if we do the bridge now and confirm, you'll see that will pop out, and this should work. If I just do a straightforward bridge, you'll see that has now worked. I would generally recommend that you leave brute force off unless you're experiencing a problem where the mesh doesn't update, doesn't conform. Brute force will obviously slow things down as it's having to evaluate the entire mesh rather than just a selection. And particularly you might notice that as the low poly mesh becomes denser, then that may become irritating and slow. So yeah, like I say, unless you're experiencing a problem, I think bridge is one of the only tools I can think of off the top of my head that experiences the problem. So you could always just use the refresh button there. Now, when it comes to conforming your low poly mesh to your high poly mesh, Wrapit will use 3 different modes to do this. By default, it's in C mode here, which is closest point mode. There's also S, which is screen space mode, and V, which is vertex normal mode. Closest point mode is what you'll be using most of the time. It's by far the fastest of the algorithms. I'll go through and compare them now. So in this example, I'm going to conform the cylinder to these spheres. And first of all, I'm going to do that using the closest point mode. So I'm just going to choose the spheres there, which have now been frozen and cached. And I'm going to choose the first cylinder as our low poly mode, making sure I'm in closest point, auto wrap there. And you'll see quite an interesting result. Now we'll compare that to the vertex projection mode. Let's just set that one up to switch over to vertex projection and wrap. Now you notice it's a little slower and the difference is quite remarkable. So what's going on here? Well, if we go back and look at a copy of the mesh how we started, in closest point mode you have to consider each of these vertices in the cylinder. Where's the closest point on the surface of these spheres? Now obviously there aren't any closest points in this kind of concave area here, and that's what we're seeing. Wrapit knows that the closest points are all along these outer convex surfaces, and that's where it's snapping to, and that's why we're missing in here. It's a lot faster, but in that respect, you could say it's not as accurate. Now with the vertex normal mode, we can just switch on, show you the normals here. If we put a edit normals modifier on, now these blue lines are showing you the vertex normals, and you can see that in this case on this object, these normals will fire straight through and they're going to hit down in these gaps. Obviously if it's a denser mesh, we'd get right in here, and that's again what we're seeing over here on the one that we wrapped with vertex normals. But we're also seeing this at the top. What's happening here? Well, if you look, what's happening here is that those normals aren't hitting anything. They're firing in, they're missing the high poly object, and in that case Wrapit will just leave them where they are. Now something to consider is that once you have actually snapped to a surface, then actually the differences between the vertex normal mode and the closest point mode really aren't great at all, and it always pays to then keep it in closest point because that's the much faster of the algorithms. So if I was to switch on now in the Vertex normal mode again, you see nothing moved. It still can't find the result for these, they're missing. And the ones on the surface, it's firing all those rays, but actually they're on the surface, so they didn't move. Now if we switch over to closest point, the first thing I imagine will happen is that these ones at the top, they will find a home because the closest point will be somewhere on here. We'll just refresh that. You see they all snap down. But again, these didn't move now. The Vertex normal got them there, but the closest point keeps them there. And it pays to just, once you've done that, to stay in closest point mode. As you can see, it's very quick. It reacts nicely. You can do things like relax all over the surface again. You'll notice that this will pull apart. That's just a problem that you're going to have in something like that. You can, of course, add a division in there and try and get that to snap closer to that point. Just move it around. It's much more responsive. So once you've done your initial projections in Vertex normal mode, I do recommend to switch back to closest point for working once you're on the surface. Now the third of these modes is screen space. Now I'm going to do a little experiment here to show you how this works. We're going to add our sphere as our high poly object, and we're going to use our good old-fashioned max teapot as our low object. Now this mode is really handy if you just want to project through camera space onto your object. So in this case, I'm going to angle the camera so that our teapot is over our sphere. Make sure I'm in screen space mode and wrap. And you saw there was a little kind of adjustment there, and it's a bit of magic because if we turn the camera now, our teapot has conformed to the surface. Now, when in this mode, you have to be very careful because again, it's generally good for an initial projection. Once you're on the surface, I would recommend, again, changing back to closest point. The closest point generally going to be fine to carry on tweaking this. If you leave it in screen space and you're not careful and start moving these around, it's going to re-project. So, for instance, if I was to now turn the camera like this, just tweak those, they've all snapped to this surface now. So it can be handy, it can get very confusing. So yeah, this can kind of be used for things like projecting pockets or panels onto surfaces like characters. Find it very handy to start off with, and yeah, move over to closest point once you're on the surface generally. Next to the low poly picker button, we have this little arrow, and this opens something called QuadGen, which is a quad-based kind of voxelization topology. So it will create an automatic topology of your high poly object or objects. I'll just demonstrate that here by selecting, I've got these primitives, I'll add all those as our high poly object, and we'll go into QuadGen, which opens a separate menu. First of all, we're greeted by the quad size, which is going to give you a rough indication of the size of the faces of your topology. It's not an actual real indication of the topology, but just gives you a visual clue as to what size your faces will be. So dial that down so you find something you're happy with, and generate. And as you can see, let's examine the object, and it will create a quad-based mesh of those objects. You can think of this a bit like Dynamesh in ZBrush if you're a ZBrush user. And there you go, you'll see the resulting mesh. Now obviously, because it's using the closest point method, you get a little bit of stretching around tight edges. Generally a bit of manual cleanup can help with that. Just to go through some of these other options here. I'd leave optimized quads on. That's basically just going to tidy up the mesh a little. Project UVs and material IDs will take any UVs and material IDs off the high res object, project those onto the low res object. Also can take the materials and the pivot from the high-res object. If we apply the rest back to Wrapit and do the same, then when the mesh is generated, QuadGen will automatically close and the mesh is sent back to Wrapit, where we can continue working with Wrapit's tools. Now, the only part here we haven't touched on so far is this distance value. Now, that will have a little offset between the low poly and the high poly object. So just to show that off, I'm just going to create a plane here. Select our sphere as our high poly. Grab that plane as our low poly, just toggle those edges. Wrap that auto closest point mode. Now, if we set those both to be fully visible, you'll notice that whilst the vertices have snapped to the surface, because it's much lower poly than the sphere below, the faces are kind of intersecting and we're not seeing that mesh as we'd like to. If that really bothers you, there is this option here where we can just push the mesh out slightly. Obviously that's now not conforming exactly to the surface, so if that's your aim, then you probably don't want to use that. But now we can see this surface as we work much clearer. Generally I'd recommend you just use the crossfader to do that. I'm not sure why you'd want to have this slightly off the surface. You could have it off the surface like this, and then ultimately at the end just collapse it down to 0 and it will snap back if you wanted to. It's there really just for your option. I think it was a request, I think, when I was making Wrapit. I generally don't use it, but like I say, it's there in case you do. So the relax section is largely straightforward, I think, self-explanatory. It's most of the settings that you'll have in the relax dialog within your editable poly object over here, but we're just using them here. Relax the whole surface. Obviously we have hold boundary on there, so it's not doing much. If I turn hold boundary off and relax, start to shrink over the surface a little bit. This is just your iterations and your amount from here, amount and iterations, and we have an option that will just relax the selected verts and a option just for relaxing a particular loop. So just select one edge and it will relax just that loop. Now within Edge Tools, first of all we have something called Extend Edges. Now what that does is, if we select an edge and hit Extend Edges, then what you'll see is it's a bit like Shift, Drag, Move an edge. It will extend it out along the surface for this value. So if I turn this value down to something a little bit smaller and extend, keep hitting extend. That's probably a little bit small to see the result there. We'll turn that up a bit. I don't know what it was on to begin with. There we go. You'll see that basically it's going to just keep conforming around the edges. You can select more than one edge and do this, and you'll see that's just going to grow over the edges. Quite handy. I use it sometimes. An example here on this corner, it will continue to shell over the surface. We also have, I think these three options probably largely outdated now. When this was first made, you didn't have automatic like loop selection in Macs, which I think you can do now. So there you go. You see that I select one edge and it selects the whole loop for me. This is an automatic edge removal, and I guess this is an insertion. There you go, and that will then just insert loops. Again, always of course conforming to the surface. Now in the spacing section, I'm just going to delete those. In the spacing section, this is about just tidying up grids really. So if we select an edge loop and do space selection, you'll see that it will evenly space the verts along that edge, again conforming to the surface. And then loops, we'll just do that for the whole loop. If you just select one edge, whole loop, and by going through like this, it's another way, other than the relax, to kind of get your grid back to a more uniform shape. So under the flatten section, again, mostly self-explanatory. Select an edge and then it will conform the loop on that edge to the axis. So if we click Z here, this will pull flat into the Z axis and conform to the surface at the same time. Again, just for tidying up topology. Obviously we have the X and Y axis, and then this planar loop, I think, basically just attempts to pull any loop into a straight line. You see there's a bit of a wobble on this one. Yeah, it pulls it straight, not along a particular axis, but I think just tight between the start and the end of the loop. Now under lock geometry, this gives us an option to exclude vertices on the low poly object from the wrapping process. So if I was to select these verts here, lock those verts and move everything away from the surface, you'll see that those have been ignored. And if we continue to do things like relax, they continue to be ignored. If we unlock them, they will snap back to the surface. Unlock them all. Or I could have, if I relock those and pull those out, I can choose to select just the locked vertices and then unlock. And that comes in handy a lot when you're working generally and you have an area that you're quite happy with and you just want to make sure that that stays locked where it is, doesn't get affected by any of the other conforming when you're working on the mesh. So the paint tools are one of the more powerful features in Wrapit. There are two modes, there's strip painting and branch painting. I'm going to start by showing you branch painting. Branch painting is used for automatically creating geometry along cylindrical objects, things like arms, legs, fingers, tentacles, you have a creature, something like that. I'll show you using this scan of an arm here. I'm going to first select the arm as the high poly object. No need to select a low poly because we're going to start straight away with branch. If we did have a low poly selected, then we could also just carry on working in branch with that. So once I've selected branch, I then click branch paint and I will select a starting point, and then I get this little gizmo thing which shows me where I'm creating my next bit of geometry. Every time I click, we do a new segment of this cylinder. And I'm just going to go up to the top like this. We probably don't have enough sides on this to do it justice around the hand there, but I'll come out of here. Now this object is going to be just the same as any other object in Wrapit. Now I'll put auto wrap on, and because that was an 8, this is the sides here, this is an 8-sided cylinder we're creating. Didn't capture much of the detail up here, but what I'm going to do is just select everything and then do a mesh smooth, and you'll see that that both divided and conformed the new geometry a bit better. We can pull some things back into shape here, and then we could do something. I mean, I'm just going to show you a rough idea of how you could use this. If I delete this geometry here, go back into branch paint, I can shift click on the surface and it's recognised that was an open edge. And if I click this tick button here and shift click, then the branch that I'm now going to create will inherit the edges from that surface. So We can carry on up to the top here. We don't have the way of closing the top. We can do that manually afterwards. I come out of branch paint now. I can select these verts around the join here. We can do a relax. Oh, I should have done that over selections and not just a selection there. And that will tidy things up a bit. Then, for instance, you could carry on up here. Branch these over here. Bridge those together. Looks a bit of a mess right now. Doesn't matter. We're just going to relax this down. Just going to pull this out a little bit here. Snap it back to the surface. Again, do what we did last time. Back into branch paint. I'm going to shift click near that hole. It identifies that as the nearest hole. Counts how many edges we've got around there. Sets up our gizmo here to carry on with that number of edges. And then obviously you'd spend a lot of time placing these a bit better than I am. Come out of branch paint. Tidy up this area again. Maybe tidy up that a little. Again, you can use all your tools here we talked about earlier for straightening up edges. And yeah, I think you can see how quick it is to block out stuff here. If you did want to close these edges, you could always cap holes. And then maybe bevel that out. Obviously, you can do that a lot better than I just have. You'll often find that it looks like things are going inside the mesh. Again, it's just because there isn't enough geometry there to hold the shape. You can see that these verts either side are on the surface, but there's nothing in here. So if we add an edge in there, often it will pop nicely back to the surface. Sometimes you'll see here it's just gone off a bit of a tangent, simply because that was the closest point on the surface. You know, it's not doing anything wrong. But often it's just a case of pulling things around and letting it snap back till you get where you want to go. I think these edges would probably want to come up here somewhere. Let that snap. Maybe you want to do a relax on a situation like that with the boundary off, and you'll eventually get something, if you've got more time than I have here, where, there you go, that's not too bad. It's starting to pull back into shape a bit there. And you can carry on working. These options here underneath branch paint are M, X, Y and Z, and they just describe how the segments are aligned, in which axis. By default it's on M, which is mouse, which means, as we've just seen, that as I move the mouse, I'm controlling, I can make it quite wonky if I do this, controlling the orientation of the next segment. If I change that, in this case, to Z and start painting, then what you'll see is that the segments are constrained to the Z axis. And obviously we could do the same in X and Y. I don't think it would make much sense on this object, but that's all they mean. Now, in addition to branch mode, we have strip mode. Now in strip mode, as you'd expect, you are painting strips of geometry on your surface. There is the freehand mode, as designated here, and that's what I'm doing now. Or if you turn over to click mode, then you'll have to basically left click and place each segment, which gives you a little more control. With both modes, you can shift click to start from a new edge. You can see that edge is designated, and you can alt click to join to existing edges. So shift, draw, alt, bridge. if you have inherit size switched on, then if I, for instance, come and branch off this wide edge here, you see my brush change to that size to carry on. And the same works for freehand mode. I'm going to just draw freehand off there. When in this mode also, you can use Control to move verts, again, whilst constrained to the surface. If you move two verts close enough together within this threshold, they will weld. Okay, maybe I'll turn that threshold. I think this is quite a large object. Yeah, you saw that there, which is very good for tidying up. So again, this object here, I can just Control and join those.